Hello to everyone, this is Shubham. In this video, I'll be continuing with the basics of mathematics that was fundamental of mathematics. So this is part 2 of it. And in the previous video, we stopped in HCF and LCM. That was the last topic we discussed. So now this video will begin with remainder theorem. All right. So the first concept for today is remainder theorem. So let us quickly discuss this. So remainder theorem says let P of X be a polynomial, P of X be a polynomial, right? Such that it is divided by X minus A. Then the remainder obtained would be or will be P of A. What is remainder theorem? It says if P of X is a polynomial and divided by X minus A, then the remainder would be P of A. So let us see what do we mean by this. Let's understand this by a question. The question says find the remainder when x to the power 3 plus x plus 1 is divided by x minus 1. All right. So this is the question. So now the solution is what the remainder theorem says, just plug in P of 1. So P of 1 would be in place of x, consider this x cube plus x plus 1 as a polynomial in P of x. In place of x, just equate this x minus 1 to 0 and get the value here. So x is 1 plus 1, so we get positive 3. So 3 is the remainder over here. Okay, I hope the remainder theorem is clear to you. Next theorem is called as factor theorem. Factor theorem. Let's see what factor theorem is. So factor theorem says when a polynomial P of x and x minus a is a factor of P of x, right, the polynomial, then P of a is equals to 0. So what factor theorem says, if there is a polynomial, P of x be a polynomial, and x minus a is a factor of the polynomial, then P of a is equals to 0 is called as the factor theorem. So let's see factor theorem with an example. So factor theorem says when P of x and x minus a is a factor, then P of x, then P of a is equals to 0. So what type of questions we can expect from factor theorem? Let's say we have check whether x minus 3 is a factor of x cube minus 6x square plus 11x minus 6. So we have to check this. Now, there is one method to check is just physically divide this polynomial, cubic polynomial by x minus 3, find the remainder. If the remainder is 0, then we can say that x minus 3 is a factor. But using this factor theorem shortcut, the solution would be, we know that x minus 3, so equate x minus 3 to 0. So P of 3 should be equal to 0 if x minus 3 is a factor of this cubic polynomial. All right, so 3 cube, then we have 6 into 3 square plus 11 times 3 minus 6. So 3 cube is nothing but 27 minus 6 into 9 plus 33 minus 6. So we have 27 minus 54 plus 33 minus 6. So finally we have 60 minus 60, which gives us 0. And therefore, x minus 3 is a factor. Okay. So this is how we use factor theorem. Okay. Now, based on these two results, what we have been learning from grade 4 and 5 about division. So let's talk about division. And this is also called as Euclid's division lemma. So using Euclid's division lemma, we know that let's understand this with an example. Let's take a number as 7 and here we have 5. So we know that 5 into 1 is 5 and we write here subtract and the remainder is 2. Okay. So what is this 7? 7 is nothing but dividend. And what is this 5 called as? 5 is called as divisor. And what is this 1? This is nothing but the quotient. Okay. And then this 2 is called as the remainder. So any dividend we can write it as divisor multiplied by quotient plus remainder. So can't I write 7 is equals to 5 into 1 plus 2? Okay, so 7 is the dividend, 5 is the divisor, and 1 is the quotient, and 2 is the remainder. Now the important thing to note over here is when do we stop the division? We stop the division when the remainder is less than the divisor. So here we'll be dealing with polynomials instead of numbers. So this 7 would be nothing but polynomial P of x, and the divisor would be something of the nature x minus a or x plus a, where the quotient would be q of x, again a polynomial, plus remainder. Okay. Now, based on this result, let us see one important question. Question says, there is a polynomial P of x which is divided by x minus 1 and leaves the remainder as 5. Then again, P of x, the same polynomial, is divided by x plus 2 and leaves the remainder as negative 1. Now the question is, find the remainder when P of x is divided by x minus 1 into x plus 2. This is the question. Now, this seems to be a bit challenging, but let's go by the definition of Euclid's division lemma. Okay, so we already know that P of x is nothing but equals to quotient multiplied by the factor, which is x minus a, plus the remainder. Okay, so let us see the first condition. I don't know what is P of x, so let it be P of x when divided by x minus 1. So x minus 1, I also don't know what is the question. So can it be q1 into x? We can assume like q1x. Okay, we don't know what is the question. Plus, what is the remainder? Remainder is 5. Call this as equation 1. Similarly, I can write P of x is equals to, when it is divided by x plus 2, so we have x plus 2 into q2 of x, right? This is the second question, minus 1. The remainder is negative 1. So this is second. Okay, now they are asking, what is the remainder when it is divided by x minus 1 into x plus 2? So let it be q3 of x plus remainder. Now, what should be the nature of remainder? This is what we have to find. So now again, let's go back and see this important fact. So when do we stop the division? When the remainder is less than the divisor. So when we talk about the polynomials, right? So if this divisor is linear, then the remainder degree would be 1 less than this, right? When do we stop this division? When the remainder is less than the divisor. So if divisor over here is quadratic, as you can see, x minus 1 into x plus 2 is quadratic. So what will be the nature of remainder? It has to be linear, and linear means what? Ax plus b. And what are the three conditions given to us in the questions? Two conditions, sorry. We are given that when it is divided by x minus 1, leaves the remainder as 5. So that means we are given with two things, that is we are given with p of 1 is equals to 5, and we are given with p of negative 2 is equals to negative 1. This is the remainder. So now if I plug in these values right over here in the third equation, call this as equation 3. So when x is equals to 1, p of 1 is equals to 5. So that means I can write p of 1 is equals to 5. So 5 equals to, now if I plug in x equals to 1 in this, so this will be 0. This complete whole term would be 0. So now x is 1. So I can write a into 1 plus b. So our first equation becomes a plus b equals to 5. I hope you're getting this. Next is p of negative 2. When x is negative 2, p of negative 2 is minus 1. So I can write negative 1 is equals to, now in place of x, if I plug in x equals to minus 2, this whole term would be again 0, because 0 into any finite number is 0. Now x is minus 2, so we have negative 2a plus b. Okay, so now we have two simultaneous equations, so we can write one below the other. We can write negative 2a plus b is equals to negative 1. So now if I subtract these two, this will become positive, negative, and positive. B and minus b cancels out. We get 3a is equals to 5 plus 1, which is 6, or a is equals to 2. Okay, so now a equals to 2. Now if I plug in a equals to 2 over here, we get b is equals to minus 1 plus 4, which is b equals to 3. Therefore, our answer is, what is the remainder? Ax plus b. Therefore, remainder answer is, just plug in a equals to 2. So that is 2x plus 3. So this is our answer. Okay, so let us discuss one more question of same type. This will give you more clarity on this concept. So let us discuss the question. Question is, when p of x is divided by x minus 1, the remainder is 2. If it is divided by x minus 2, then the remainder is 2. Question is, find the remainder when divided by p of x is divided by x minus 1 into x minus 2. This is what we have to do. So do try this question. At the end of the video, I'll tell you the answer for this one. Okay, let's discuss one more type. Second question is, find remainder when x to the power 135 plus x to the power 125 minus x to the power 115 plus x to the power 5 plus 1 is divided by x cube minus 6. So one way to solve this question is physically divide by long division method. Another one is, I don't know what is the quotient. Okay, so we can basically write it as x to the power 135 plus x to the power 125 minus x to the power 115 plus x to the power 5 plus 1. According to Euclid's division lemma, this is our dividend is equals to divisor, which is x cube minus x into, I don't know what is the question, so let it be q of x and some remainder. Okay, so now what will be the nature of remainder? So the nature of remainder would be quadratic, because here the divisor is cubic. So remainder is of the form ax square plus bx plus c. Now I can basically simplify x cube minus x as x into x square minus 1. And what is x into x square minus 1? X square minus 1 is nothing but x minus 1 into x plus 1. So I can write it as into q of x plus the remainder. And remainder is x square plus bx plus c. So now what are the critical points? So the critical points over here is x equals to 0. So if I plug in x equals to 0, what I'll get? 1 over here. So if I plug in x equals to 0, 0 into all these things is 0. So we basically get a into 0 square plus b into 0 plus c. So therefore our c value is 1. Now if I plug in x is equals to 1. So now see this. polynomial, what do we get? 1 to the power 135 is 1, plus 1 to the power 125 is again 1, minus 1 to the power 115 is again 1, and then 1 to the power 5 is plus 1, and then plus 1. Okay, so we have 4 minus 1, which is 3. So we get 3 is equals to, what is the nature of remainder? Ax square plus bx plus c. So a into 1 plus b into 1 plus c, and we know that c is already 1. So from here we get 3 equals to a plus b plus 1. Therefore a plus b is equals to 2. Call it as equation 1. Now third critical point is x equals to minus 1. So at x equals to minus 1, we again have, what is our polynomial? Let's recall this. So at x equals to minus 1, we have minus 1 to odd power is negative 1. So we have negative 1 minus negative 1, and then negative is already there. Again negative 1 to the power 115. Odd power will give you positive 1, and then again negative 1 plus 1. So this is what we get. Now this thing is equals to, so minus 1 plus 1 cancels out, minus 1 plus 1 cancels out. We have minus 1, a into minus 1 whole square plus b into minus 1 plus c. So here we get minus 1 is equals to a minus b, and c is 1. So we get a minus b is equals to minus 2. Call this as equation 2. So now we have two linear equations. I can solve it. A plus b is equals to 2, and we have a minus b is equals to negative 2. So when we add these two, b and b cancels out. We have 2a equals to 0, or a is equals to 0. All right. So if a equals to 0, that means b is equals to 2. So b is equals to 2. Now what was our remainder? Our remainder was of quadratic nature, ax square plus bx plus c. A value is 0, so we get 0 into x square. B is 2, so we get plus 2x, and c is 1. Final answer is 2x plus 1. So this is your answer. I hope you understood this. Next concept is about consecutive numbers and its divisibility. This is very, very important. So the note is, make it as a note. This is a proven result. It says the product of our consecutive, numbers is divisible by r factorial. Okay, always. This is a very, very important result. So based on this result, we have a question. Prove that the sum of even integers and its square, prove that the sum of even integers and its square is even. Okay, so even integer and its square. So let the integer be n, and then we have plus sum of even integer, right? In general, we are talking, so n plus n square, their sum is even. So how do we know whether a given number is even or not? So if a number is divisible by 2, then we call it as a, so from n and n square, can we take n common? So we get n into n plus 1. And what does this result says? Isn't it two consecutive numbers? These are two consecutive numbers. So two consecutive numbers are divisible by r factorial. So r consecutive numbers are divisible by r factorial. Therefore, two consecutive numbers will be divisible by 2 factorial. And if it is divisible by 2 factorial, that means it is divisible by 2. And this implies it is even. Hence proof. Right? You can check this. So let's take any two numbers. This result, let's take two consecutive integers, 3 and 4. Okay, so these are two consecutive numbers. So the product of 3 and 4 is 12. Right? And 2 factorial, so it is divisible by 2 factorial. The answer is 6. Alright, so this is a very, very important result. Now similarly, let's take another question. It says, is n into n square minus 1 divisible by 6? Or you can say, is a multiple of 6. Question is n into n square minus 1 a multiple of 6? Another way of putting it. Okay, so the solution is, can we write n into n square minus 1 as n into n square minus 1 can be written as n minus 1 into n plus 1. Okay, so these are three consecutive numbers. So three consecutive numbers using the theorem or the result over there. These are three consecutive numbers, isn't it? N into n plus 1 into n minus 1. So if these are three consecutive numbers, they will be divisible by 3 factorial. So they are divisible by 3 factorial. And what is 3 factorial? 3 factorial is nothing but 6. So they are divisible by 6. And that is what we have to prove. Right? So therefore it is a multiple of 6. So I hope you get this. Now let us talk about the next topic. That is ratio and proportion. So the next topic is ratio and proportion. So what is a ratio? Ratio is nothing but any two quantities divided by one another. So let's say A over B is a ratio. Okay, there are two quantities, A and B. And what is a proportion? If you have A over B is equals to C over D, that is a proportion. Okay, equivalent ratios are nothing but they're in proportion. So now let us talk about what are subduplicate ratios. So if in the question it is given that subduplicate. So what do you mean by subduplicate? Subduplicate of A by B. So it is nothing but square root of A and square root of B. Do we also have subtriplicate ratio? Subtriplicate ratio would be 1/3 root of A and B. Okay, so this would be A to the power 1 by 3 divided by b to the power 1 by 3. All right. Now let us discuss about the important results based on ratio and proportion. Let's see what are those. The first result is if three numbers a, b, c are in continued proportion, such that we can write a is to b. Continued proportion means this a by b is equals to b is to c. So I can write it as a over b is equal to, because this 4 dots means the proportion symbol. So this ratio a by b will be equal to b over c. And when we cross multiply, what we get? B square equals to ac, or b equals to square root of ac. Okay. Therefore, what do we mean by this? Therefore, these are equal, right? A by b equals to b by c. They are equal. And what it means? Second term divided by first term. So GP. So A, B, C are in GP. Okay. GP means what? Common ratios. Okay. So what is the mean in GP? If three terms are in GP, what is the mean? B equals to under root of AC. Now, next important concept is called as componendo. This is very, very important, which usually we don't teach in school. So the name says componendo. Okay. So what it means is, let's say if two ratios are there, such that AB is equals to C over D. So what we can do over here is just add 1 to both sides. Can we do this? Yes. Plus 1. So what do we get? A plus B by taking LCM over B is equals to C plus D over D. As the name says, componendo, right? So A plus B numerator is added by the denominator. This is componendo. Next concept is called as dividendo. Dividendo. Okay, so let's see what it is. Here we have A over B is equals to C over D. Now here in componendo we have added 1. So here what we will do, we will subtract 1. So minus 1 equals to C over D minus 1. So when we solve it further, what do we get? We get A minus B divided by B equals to C divided by D minus D. C by D over D. Okay. Now when we combine these two, that is called as componendo and dividendo. What is this? So it says if A over B is equals to C over D, right? So here we have to add the numerators. First add the numerator A plus B, and then subtract here A minus B equals to C plus D. Add in the numerator and subtract in the denominator. Okay, this is called as componendo and dividendo. Now let us see what is the practical use of these concepts in the question. So now let us take one question. The question says, find the inverse of y minus 2 is equals to 10 to the power x plus 10 to the power minus x divided by 10 to the power x minus 10 to the power negative x. Okay, this is what we have to find, the inverse of this. Basically, how do we find the inverse? To make x as a subject. Okay, so now here there is no conventional method, right? So x is there in the numerator, and that too as exponent of 10, right? And here we have negative x. So just by looking at this problem, it becomes very cumbersome, right? It looks very hectic, right? So to separate x, so here, as we can see, there is 10 to the power x, and we have in the denominator as 10 to the power minus x as well. So once it is added and once it is subtracted. Okay, so just by looking at this expression, we can make sure that this is related to componendo and dividend. Now, componendo and dividendo can be applied when there is a ratio on LHS and RHS. Okay, so LHS part, it should be in ratio form. So let's discuss the solution here. So I can write left hand side as y minus 2 divided by 1 equals to 10 to the power x plus 10 to the power negative x divided by 10 to the power x minus 10 to the power negative x. So now apply componendo and dividendo. So what componendo and dividendo says over here, I'm applying componendo and dividendo. So subtract the numerator, right? No, add the numerator, y minus 2 plus denominator divided by y minus 2, whatever is the numerator, then you subtract it by denominator. Okay, slowly. So 10 to the power x plus 10 to the power minus x. Here we will add the denominator plus 10 to the power x minus 10 to the power minus x divided by, subtract the numerator by denominator. So 10 plus 10 to the power minus x minus 10 to the power x minus 10 to the power minus x. Right. So we have reapplied componendo and dividendo, which was already given in the question itself. Okay. So when we solve this further, let's see. So numerator over here becomes y minus 1 divided by y minus 3 is equals to, when you open the brackets, 10 minus x, and minus cancels out. So we get 2 into 10 to the power x divided by, in the denominator, 10 power x, and 10 power x cancels out. Negative becomes positive. So 2 into 10 to the power minus x. Now we can cancel out the common factor 2. So we finally get y minus 1 divided by y minus 3 is equals to, now this is nothing but 10 to the power 2x. Okay, now we have to make x as a subject, right? So we have to find the inverse. So here we will take the log. So if we take logarithm both the side to the base 10, obviously. So log to the base 10 is equals to y minus 1, and y minus 3 is equals to log of 10 to the power 2x. So this power will come in front. So we have 2x log of 10 to the base 10. And here we have log of 10 y minus 1 divided by y minus 3. Now further solving it, log 10 to the base 10 is nothing but 1. So we get 2x is equals to this log of y minus 1 divided by y minus 3 whole thing to the base 10. And therefore x is equals to 1 by 2 of this. Now this x is nothing but f inverse of x is equals to 1 over 2 log of y minus 1 divided by y minus 3 to the base 10. Okay, so this y, we have to change it by x. So make it x now, because we have to find the inverse function. So this is our answer. Okay, so that is the practical use of componendo and dividendo. It makes our question very simple. Otherwise, it is very difficult to solve these kind of questions. So I hope, friends, you like this content. Thanks for watching.